Good morning, everyone. Hope you all had a good weekend.
Oh,
I know you did. We talked before class, Sean. I'm really pleased that you had a great weekend. You did a lot of
yeah,
exciting things.
awesome.
And Ed, I was at your basketball game on Friday night. I think it was 12 points that you scored. Nice job. Nice job.
Thank
Uh,
you.
You're welcome.
I know that was amazing, like how you got that free throw. That was so cool.
It was cool. Very cool. Anyway, so we're going to start today. Last Friday, just want to bring you back because the weekend sometimes people have a tendency to forget what we did, where we were, what we learned. So I'm going to start today with just a quick reminder. Last Friday, we went over the test that you took on Thursday, and the tests were understanding commutative, associative, distributive properties, and also on multiplying monomials. Yes, you did a great job. Very pleased with your understanding. Hold on, Sean, hold on. We're pleased with your understanding of all those topics, and today we're going to build on it. So like every class, when we start a new unit, we always start with what our question is going to be. So our question today is, how can we multiply now binomials by binomials? We've done monomials by monomials, and we've done the distributive property, the associative property, and the commutative property. So we're going to build on that. Also, just as a reminder to all of you, remember whenever we do a new unit, we always have questions about, well, what if this? What if that? How, what if this happened? Right? And what do we do with those questions? If we can't answer them right away, we put them on our wondering board to the side. So when we did the commutative property, I think it was you, CJ, that said, hey, Mrs. H, how come we can't use the commutative property with subtraction? We put that on our one. You remember that?
Yeah.
We put that on our wondering board, and we were able to answer it together and solve that dilemma.
I forgot already what the answer was. What is it again?
What was the answer on the commutative property? Do you remember?
Yeah.
Do you remember, Maria, why you can't use subtraction with the commutative property?
Well, it doesn't work
How? Why doesn't it work?
because it's subtraction. It's a totally different answer.
Anybody can give an example. Sean, can you help out?
Well, yeah, like so if it's like, say if it's if it's a minus number, then when you do it over on the other side, it'd be a totally different answer.
All right. Can anyone give me an example? How about you, Kevin?
Oh, wait. It's like, what are we doing, subtracting?
On the commutative property, give me an example of what it would look like.
All right, so say you have like, like what, x, no, so say you have like, x times and then parentheses 5 minus 3. And then on the other side you have, like x, then.
The other side meaning what? What do you mean by the other side? What do you think, Ed? What does he mean by the other side?
I'm not really sure.
All right. Anybody can help him out? Sean?
Well, the other side, that's like the other side of the equation.
Other side of the equation. Good job. Okay, Kevin, continue.
Yeah, right, so the other side's got like, x, and then in parentheses, like, I don't know, 5 plus 3 or something. It's like you couldn't switch them around because if you did that, then it'd be like different. Because one's plus, one's minus, and so it's not gonna work.
All right, so those would be different. I'm going to put that on our wondering board because that has something to do with another property that we're looking at. Let me throw this out to you. You ready? I'm not going to forget about this. This is going to go on our wondering board. We'll work with that afterwards. If I said to you 5 plus 3, is that the same as 3 plus 5? Think about it. Kevin.
Yeah, that's the same.
Okay, why?
Yeah, that's the whatchamacallit, the, like what you just say, the commutative property?
The commutative property, excellent. Maria, do you agree?
Yeah.
Okay, you agree, so that 8 equals 8. And what we were saying to CJ's question last week is 5 minus 3 the same as 3 minus 5? Think about it.
Well, of course it's not the same.
Of course it's not the same. CJ, what is 5 minus 3?
5 minus 3 is 2. That's so basic. That's like baby math.
Okay, well give me the baby math on the other side too. What's 3 minus 5?
Well, that'd be like -8.
All right, -8. Agree or disagree, Sean?
No, that's not right, because that'd be like -5 minus.
Agree or disagree? We don't say something's right. Agree or, right or wrong? Agree or disagree?
I disagree.
I disagree. What is 3 minus 5?
Well, 3 minus 5 is -2.
-2. And we know that 2 does not equal -2. This is the commutative property. It does not work for subtraction. All right, let's move on to what we're going to do today. Plan for the day is we're going to review important terms. We're going to review the rules, and we're going to begin to multiply our question, to answer our question, how do you multiply a binomial by a binomial? All right, you all set? Yes, I can see CJ's raring to go. All right. Who can give me an example of a monomial? Ed?
Yeah, so a monomial, that's like a one term, it only has one term.
It only has one term, okay. Can you give
Yeah.
me an example of a monomial that has one term, but it has a variable as well
Yeah.
as a number?
Would that be like, 10x? something like that?
10x, okay, I like it, 10x, good. All right, who can give me an example
That's weird.
Sean, did you have a question?
Well, I was just gonna say, cause like, have you ever heard of like when we were making cookies one time, and this was like the powdered sugar is also called 10x sugar.
Great. I have some of that. I keep my 10x sugar in the refrigerator. It's confectioner sugar. That's the
Oh
other
yeah,
name
that's a
of
good
it.
idea, cause that keeps the ants out.
That's right. I have a lot of ants in my house, especially during this wet weather. Okay, Kevin, are you with us?
Yeah, where else would I be?
No, you wouldn't be anyplace else. Okay, so this is a monomial, right? Can someone give me an example of a binomial? A binomial using a variable and also a number.
Binomials, like that's a number that goes both ways.
Yeah.
Oh man, girl, you're so crazy.
Yes. All right, you got one, Kevin?
Right, yeah, I got one. All right,
Go
so
ahead.
binomial, that's like, it's gonna be like two terms. So it's be like, so you 4x plus, I don't know, 3 or something.
4x plus 3. A binomial, why a binomial, Maria? Why is this a binomial?
Because it's two terms. 'cause
Two
it's
terms.
Two terms that are separated by plus or minus.
Plus or minus. Good
Okay.
definition. All right, so here we're going to multiply a monomial by a binomial. And you might be saying, well, Mrs. H, wait a second. We're doing, wait a second. We're doing binomial times binomial. We're going to get to it, CJ. All right, let's multiply 10x times 4x minus 3. Monomial times a binomial. We're going to use the distributive property, right? Remember that?
Yeah.
Sean, you with me? I'm over here. Okay.
That's where you do it, like, you distribute the function across the different parts.
You distribute the function or the monomial across the different parts. What's 10x times 4x? Think about it.
It's a neat
Think about it. CJ?
40x.
Maria, right? Agree or disagree? 40x. Maria, agree or disagree?
I agree.
You agree? Okay, Sean, what about you? Agree or disagree?
I disagree.
All right. What about you, Kevin? Agree or disagree?
Man, it's CJ's answer, I agree.
Better.
All right. What about you, Ed? Agree or disagree?
I'm not really sure, to be honest.
All right. See, now at this point I would stop and I would go back and I would do a mini lesson on multiplication of monomial by a monomial, because they need to have that in order to be able to do the next step. So I'm going to stop with that, because you don't need to see where I would go backwards on that. But again, that would be a conscious decision that I would make, because my questioning of them, of their background knowledge, elicited the fact that this is still an area of confusion. So I can't move on until they have that. So that's it.
So,
You're finished with math now.
oh, no way. We're just getting started.
You can use those sharpened pencils though for the next lesson.
Right.